Let's talk about our long-forgotten ancestors. You start with your parents, and then parents' parents, and repeat until you go back 100 million generations. That ancestor is a humble fish in the ancient ocean. What stupefying odds it had to beat? How did they make it? I'm Tetsuto Miyashita, a paleontologist at the Canadian Museum of Nature, and I'm here to tell you about my new research that sheds light on that question. I'm holding a 400-million-year-old piece of sandstone from an Arctic island. There are thousands in the collections like this, but it took some luck to find a tiny fish in just one of them. This fossil is a jawless fish called Norselaspis, your very distant cousin in the Devonian period. The fish is so tiny, it sits right on my little fingernail. Now we took that fossil to a particle accelerator to shine a high-energy X-ray beam to see what's inside the fossil. Now here is a magnified model of the brain of Norselaspis. Now, as you can see, the half of the length of the head is occupied by this big eyeball, and then here, the other half is the big inner ear. This is where fish can maintain the balance and sense vibrations. If we scale this up to our human dimensions, then these inner ears would be like a pair of avocados in the head, and that would make the heart of Norselaspis the size of a cantaloupe in the chest. Such a massive heart is what Norselaspis needed to paddle its pectoral fins, making quick turns, bursts, and stops. So this tiny Devonian jawless fish had very acute senses and a lot of horsepower, just like that sport car with all the safety features built in. These adaptations would make Norselaspis excellent at detecting and escaping from predators. Eventually, fish evolved jaws and teeth, and then the hunted became the hunters, astute and agile, thanks to the adaptations acquired by their jawless ancestors. Some jawed fish evolved to live on land as four-limbed animals, and then some eventually grew hair, stood upright, and then learned to talk. That's us. Until now, we thought that the fish evolved jaws and teeth first, and then got faster and smarter so that they can catch more and more food. But with this discovery, we know that it's the other way around. Because primitive jawless fishes already had their wheels, so to speak, their descendants with jaws were able to dominate as effective predators. Even the slightest of our movement requires the sensory and the locomotory innovations first seen in the fishy ancestors, which we share with Norselaspis. In our busy lives, we often forget that everything we do has a deep evolutionary connection to the Devonian Ocean 400 million years ago. So next time you feel your tax returns, or make a sushi roll, or catch that fly ball in the outfield, think about Norselaspis and friends, and visit the museum to discover more about your evolutionary heritage. Meanwhile, I'll head back to the field to collect a few more hits.